today's topic will be mostly on control systems design and development for automotive applications. So we'll be discussing on the same. So just going with the overview, we would be going into the introduction and then the current state of the art controls in automotive space, and then who are the leading software solutions provider, as well as how about the leading hardware solutions provider, and then we would be going into the current trends, some of the market studies and surveys, and then typical job roles at a very entry level for the developers and for young developers with almost 2-3 years experience, and then we will be moving into job roles for senior and top management level, and then we will be focusing into one of the case studies, and finally I'll be guiding you how you can be part of this role, or you can take up this role in your future. So let's get started. Yes, so basically, what is the state of the art of current control systems in automotive space? As you can see, we'll start from the left hand corner. So basically, if we look into automotive domain, we can segregate automotive domain into basically two types of different vehicles. One is on-road vehicles and the other is off-road vehicles. So as you can see that on the left hand side, mostly we are talking about, so what comes to our mind when we talk about on-road vehicles currently? So we have, obviously we have driverless cars, and mostly the world is moving fast on this research, and we are on a very preliminary phase, and control systems plays a very vital role in developing the algorithms and determining how smooth we can go for actually getting a real driverless cars on road. So as you can see, it's one of the pictures on the left hand side saying the electronic control stability, how it's annotating how we can avoid skid and what are the applications of controls in getting the electronic stability or the ABS system mostly. And then we obviously have lane keep assistance also as part of the driverless behavior or ADAS systems behavior by the cars. Obviously, these functions, as you can see, the adaptive cruise control, front collision warning, lane departure warning, lane keep assistance, lane change warning, parking assistance. These are all the ADAS features, or rather, the ADAS systems will be assisted with these many features and controls. As I already told, that control systems plays a very vital role into this. So what about a control systems expert, or what are the roles of a control systems expert? So control systems expert, or rather control systems design and development is a vast area, and is also a multidisciplinary area in which you have to have many things into your mind, into your skills. Likely you need to understand system engineering, you need to understand mathematical modeling of systems, you need to understand AI/ML models, you need to understand machine learning, you need to understand also some part of electronics. So as you can see, there's an ECU functionalities of today's car. So there are a lot of functions or functionalities that are being automated in today's car, and there are multiple ECUs that operate for today's cars, and these features are moving on, and the complexities are moving on and on. So taking care of driverless cars, we see the requirements are very complex, and pretty complex requirements we have. We also have complex control systems that has to be understood, so we have to capture the requirements. There are specific tools that captures the requirements. Also we have sensors and actuators, so we have to model the sensors and actuator accordingly, so that we can enable driverless cars to have a smooth and a safe journey for the passengers. Also, we are moving from ECUs to DCUs. ECUs are electronic control units, to DCUs are distributed control units. So mostly they are heavier ECUs where you have, so currently there are multiple ECUs that are involved in in some of the operations, but with further goals of, so there are something called AUTOSAR standards, and we'll come into that later on, might be, so which are aiming for reduction of number of ECUs to lesser number of ECUs to be part of it. If you can see it on the left hand side, we have an off-road vehicle, which involves complex requirements. So this is typically an off-road vehicle of one of the top tier companies. You can see John Deere system basically, and they are involving multiple issues as well as safety performance as it comes to agricultural vehicles. Okay, so coming back to the next slide, we have so who are the leading solutions provider or software solution provider rather. So we have TCS in the game. TRDDC is an R&D wing which does an extensive work in control systems designing and control system modeling basically. Capgemini is also playing a crucial role into it. Altran is a France-based company, is a French company actually, and Capgemini has recently acquired also Altran. So basically, Capgemini will be playing a more crucial role into automotive domain now. KPIT is one of the other names that that is into the space. Hella Automotive is another one. Continental, Bosch, Delphi, as well as IT services. Some of the IT services like Wipro, HCL, L&T, Infotech, Mindtree, and few more. So the space is moving on and on as we come into leading hardware solutions provider. So here hardware, we are specifically meaning the semiconductor manufacturers who are actually manufacturing ECUs for them, or ECUs or DCUs for these companies. We are not meaning OEM by this. So basically Bosch is one, Continental is also, so they can also be addressed as tier 1 suppliers for automotive. Delphi is another one. Renesas is having their own space into it. Infineon as well as Hitachi. There are a few more I can go on naming, but just these are the lead players mostly. And very interestingly, just to get back to you, for both of the list, India, their India center or India TCI center is actually playing a lead role. So I mean, there's a lot of scope for there's a lot of requirements for young engineers as well as for experienced engineers, and in India as well as abroad. So we'll be coming back to what are the typical job roles at the entry level for India as well as abroad. So we are looking for, or rather there's a dearth of embedded systems engineer by the OEMs. And actually there are embedded systems engineer and people around, but getting some good experience in embedded systems will help you to get this kind of roles. Okay, and mostly they are provided by OEMs. OEMs mostly are the original equipment manufacturers, either on the off-road vehicle or on the on-road vehicle. Off-road vehicle, we have CNHI, we have John Deere, we have Mahindra and Mahindra. Tier 1 and 2 also we have a few of them. We'll see in one of the slides. We have, okay, if you are enthusiastic in the control systems and design, you have certain roles like plant modeling engineer, where you will be your primary role will be to develop plant models for the systems. Simulations engineer, systems engineer, which systems engineer is a very vague profile, and in IT industries or in service providing industries, I think the preliminary role comes with system engineer, but in mostly OEMs and tier 1 and tier 2, mostly where you have a have a good role in capturing the systems. System engineer, or rather system engineering, is a very vital and pivotal role. So the other one is already an automotive engineer, which is already on demand for OEMs, and both for on-road as well as off-road vehicles. We have a few of the OEMs as well as tier 1 clubbed together here in this slide. You can see BMW Group. Most of them have their TCI centers here in India. We have Bosch, we have Continental, we have Daimler, we have Ford, We have GM. GM is, I think they have retreated back from India currently. We have PSA Group, which is in infotainment mostly, and also Toyota. Now coming to the food chain of automotive control softwares. So mostly, as you see, this is the part of a consortium. This slide has been taken from AutoSAR consortium, but I thought it would be a good thing to know the food chain. So these are the OEMs. As you see, Hyundai, Kia, Honda, Mazda, as well as Nissan, Porsche, Volvo, and Fiat. They are being supplied by the tier one suppliers like ZF, Visteon, Valeo, Lear, Denso, Delphi, Autoliv, as well as Hella. And there are certain standard software and tools and service providers, as I told you already, like Altron, KPIT, MathWorks, FEV. So they are very common and very familiar names. As well as for hardware and semiconductors manufacturing, we have Renaissance, we have Hitachi, we have Infineon, and obviously these are the core members or the OEMs mostly we are addressing to, where we have PSA, Ford, as well as Continental, Daimler, and BMW, and so on. Okay, so currently coming to the Indian automotive scenario as per Feb 2020. So I am pretty sure that you all are very much aware of the booming automotive market. Currently, it's not into a very good phase right now, but as soon as the market gets stable, mostly the industry is working on electric vehicles. The all over electric vehicle revolution is around, and there are different type of car segments that are also coming in. So we have in India, we have mostly Nissan, we have mostly Maruti Suzuki, which acquires around, sorry, we have mostly Maruti Suzuki, which acquires more than 50% of the market, as well as after that we have Hyundai, and we have, I think then we have Kia. Kia is just into the play, and we have several others like Mahindra, Honda, Ford, Kia, and so on. So Honda takes 2.9% of the market. So and the interesting fact, I mean, is mostly all of their control systems role or embedded systems development role or mostly control software development role, which we are speaking about, is focused or have their TCIs in India. And so there's a good chance of young crowd and energetic crowd and eligible crowd to get absorbed into these companies. Getting into the world scenario, this is a bit old data. This is a 2017-18 data, but again, nothing much has changed. Much has changed on this part. So mostly the largest provider or the largest manufacturer or the exporters come from Germany, which is contributing in $151 billion in the car industry. And after that, mostly US. You can see the southern part of US, mostly California and those areas, as well as you can see Japan is contributing, China is also contributing after electric vehicle into revolution, which is not accounted in this data. China is contributing pretty large into this, and obviously Spain, Belgium, and so on. So these are mostly the key players. India is booming up. Now the next thing is what kind of job roles we can expect in the senior level of around, if you say if you have a 15 to 20 years experience down the line, if you work on these areas and if you have picked up some of these skills, where do you see yourself in next maybe 15 to 20 years? So these TCIs or these companies mostly have some certain roles specified, like technical specialist or engineering fellows, technical fellows. And there are companies like or TCIs of companies like MBRDI, Mercedes-Benz Research and Development India. We have John Deere TCI in Pune. We have CNHI TCI. We have Mahindra and Mahindra TCI as well. Okay, and what all skills you need or what all different roles for technical specialists you might have. are like something like plant modeling and simulations experts. You need virtual validation experts. So nowadays coming the computational power coming into picture and play and ruling the world mostly. So we don't validate things, or we don't verify our models, or our ECUs or our algorithms direct onto cars. So because the virtual platform or the virtual engineering platform is so strong that we validate our algorithms there. So obviously, virtual validation experts are also in demand. Digital twin is a new subject, is a completely new subject, and it falls in line with these current expertise of control systems development. Digital twin as well as advanced control systems. Obviously, you know AI/ML is all around. AI/ML algorithms is being used in mostly all of the algorithms we are developing for either driverless cars or for off-road vehicles, or for sensor data actuations and everything. Okay, so the different kind of top management role that we have is like VPs for virtual engineering. Top OEMs require, and they hire a pretty looked after position, and it's on demand. It's on hot demand, and GE is one of the top niche companies that is hiring mostly on virtual engineering. They are having some virtual validation platform in which they are working on, and they are working on this. So basically, what all skills they are working on, or what all teams they are rather handling. So if you are looking into a position like VP for virtual engineering, they'll be handling digital twin teams, they're handling manufacturing engineering teams, as well as embedded systems and design development teams. So as you see that, as I told you, that control systems is a multidisciplinary area, and there will be, you need to have your hands on in different subjects, and your interest also in some different areas, so that you can master the skills and use it accordingly. And I promise you, it will pay you a lot in your career if you look further with your career graph. Okay, then coming to the vice president ADAS systems, mostly companies, tier one companies like Google and Uber, they are having a pretty legal issues now for with one of the top tier engineers and VP for ADAS. You know, you might be, it's on news. So it's also there are companies like KPIT and also Capgemini Ultron, as they have Capgemini has acquired Ultron. So there are VP positions who are specifically recruited for ADAS systems development, and what all divisions again come with them, or what all different heads come with them, are like sensor fusion engineering, algorithm development teams, embedded systems team, validation and verification team. So basically, you can understand it well that you need to have these different skills also to reach to such a position. Okay, the next thing is obviously AI, ML, and advanced controls. Again, companies like Hela, Ultron, and other companies are hiring for algo development for ADAS domain, advanced controls modeling, system engineering, data science analytics is also a hot cake these days. So now talking about the scenario, now we need to understand that let us take some case studies, a pretty smaller, will not go deep into that, but again, just to give you a glimpse that how can you match your academic skills with the industries on this, because you would be asking, right, whatever skills I have, I understand a pretty mathematical model of a system. How can I map that into a product, or how can I, so suppose if I have a pretty small parts of bits of code, how can that be embedded into the product, and how can that be tested? So okay, so this scenario, the first one is mostly speaking about ADAS systems, where you have all the sensors, you have all the camera, radar, lidar, as well as navigation sensors, which is acquiring information, and there's a sensor fusion algorithm that is going inside it. You take all the sensor data, you design a control system model with it, you develop a ADAS controller with it, and you develop all these algorithms like adaptive cruise control, lane departure, other application algorithms, collision mitigation, braking, and all these algorithms with it. You have your driver behavior analysis with it. You have all those models, all those data clubbed together, and then what you do is you act on the actuation system. So if you look for a very basic model of what you read in your controls book is an open loop system and a closed loop system. This actually forms a pretty closed loop system in which the sensors and actuators are treated as they are forming a closed loop with the driver coming into picture or with the controller coming into picture. So this is how, and with the actuation you have the brake systems, the steering system, suspension system, the powertrain system, as well as the battery systems. Now, as you can see it, I have given an example of a suspension system where you have a mass and a brake and a damper, as you can read it in your books. Mostly, if you flip back and go for your control systems model in Ogata and all, you will find a spring damper system. So now I will speak and we'll see how those theoretical models can be implemented and how can we realize that in the industries. So we have, this is a pretty familiar V-cycle model that we have. So how do we decode this, or how do we actually embed all of these models and then make a proper ECU rather from development to the testing phase? So we have all the control targets, we have all the requirements, we go for the control system configuration, we have the controller design and the simulation models. After that, so this is, as you know, the left hand side of the V-cycle, which contributes to the development, and the control software requirement specification you have, and then obviously you use MATLAB and Skill-Lync extensively for this, and then you will be having code generation into it. So you develop the models and you decode, you develop auto-generated code out of it, and then you go for software verification, the ECUs, embedding them into ECUs, controllers, and then calibration it, and then calibrating it, and then finally going for the validation. And in between these, something that comes across are like either software in loop systems or model in loop systems or hardware in loop systems that comes into play. So let's get a bang on a problem into it, in which we have a very an overall system, and you need to, suppose you have a Mercedes-Benz MY 2025 model, and you need to increase the spring damper system or the suspension system of the car basically. So how do designers or how do control engineers act, or algorithm engineers act on it? So what you do is you go for a mathematical model directly from the current model. You go into a mathematical model, you come into a spring damper system. As I told you, this might be very familiar with you, with the theoretical models that you have read in your chapters. So fine, you have these models, and then from there what you do is you develop the theoretical model, and then you go for a pretty detailed model, or something called high fidelity model, in which you write an algorithm in Skill-Lync, or you develop blocks in Skill-Lync, and then you do a code generation. So after developing the logic into it, what you do is you do a code generation, you develop .hex files, .elf files, and then you come into this layer of embedded systems where you have, so this is a microcontroller layers, different layers of the microcontrollers, how they act. And you can see this is an application layer in which you have the engine controls algorithms there, or engine controls payloads there. Basically, we call it as payload. The sensor actuators control payload, as well as the powertrain control. So different payloads will be attached in the application layer after they are being modified. And so these are different AutoSAR layers, which are a BSW layer, as well as the MCU layer and the MCAL layer and all. After that, what you do is, after these are being embedded, you go for a dry run and you go for validation through different hardware in loop, software in loop, model in loop, and then finally you embed that algorithm, or you embed that piece of code into the ECU, which takes care of the mass and damping system, and which rather improvises the spring damping system into it. Okay, so yes, that's it. So that will tell you about the entire cycle. Now, how to get here and how to get this kind of roles. And as I told you, it's a pretty niche and a high paid skill set. So obviously you need to understand and have inclination towards different fields of different fields. Like mathematics, you have to have inclination with towards mathematics, engineering, as well as data. Data is always ubiquitous these days, and data science and data engineering is a big part of the field. So you can embed your knowledge of AI, ML, and data analytics into this field. You have to have your basics of control theory, obviously linear control systems, classical control systems, and there's a pretty much myth there saying that your academic models or your academic so even when I was in my academic days, I used to hear rumors from seniors and people that your academic models or your academic things doesn't apply to the real field. But here in control systems, I would say that you can easily see that your basic models, or if your basics are very much correct and whatever you have learnt about, suppose you go for a linear control or classical control theories for suppose you go for a basic stability model of route service stability, you can actually apply that and apply that maths and implement that in your model. So obviously, classical control system, stability analysis and modeling, you have linear algebra. Linear algebra must be a bit strong from your side. Believe me, I am not here to scare you. These are different fields, and you don't need to be scared about these fields, because you just need to understand some basic concepts so that you can apply them on your models or on your career in your career. So again, advanced control systems, system identification, neural network, machine learning, supervised, unsupervised regression models, Kalman filtering design is obviously a very high niche area, niche field. Practice with tools, obviously you need to not only read the theory, you need to do it on burn your hands with some of the tools like MATLAB, Simulink, Stateflow, Octave is another one, Python and R. Some basics of coding with C and C++ is encouraged, because at times you need to understand when you are developing models, you are dumping those models, you have pure form of embedded C codes. So you need to understand some basics of code. AI/ML tools for data processing. Obviously, you have different tools again. Minitab is one of the statistical tools, Python and R, as well as MATLAB for statistical analysis, and embedded systems. So embedded systems, you need to understand, or you need to just try small things with Pi4, PX4, different type of smaller controllers that you have. And obviously, last but not the least, it's a multidisciplinary approach towards system engineering. So it's a niche and a high-paid skills. Just for your data FYI, an average salary of a control systems expert in the industry of around 7 to 10. It's a very rough and expected figure. I can't go dive in for a particular figure because it varies across. It's varies from 12 to 22. I think few companies pays more than 22 as well at times. So which is obviously 22 lakhs per annum is also not too bad. As well as if you go for very senior roles and if you have such kind of expertise, obviously you expect for a raise for more, and sky's the limit. So for everything in basics, as I told you, nothing to worry about all this big syllabus or the big terminologies that you see that, okay, I have to understand all of this. If I need to understand, or if I need to be a control systems expert, do I need to understand all of them? Yes. But basic things that the industry works is obviously an open loop and a closed loop control systems model. This needs to be very clear, and I hope it's a very simple thing. You all must have been very acquainted with this model, which is a controller and the plant as well as the feedback sensors. Okay, so we all play with this basic models and some basic mathematics and some basic algorithms.